Welcome guys! Today I'm going to be demonstrating a proof of a very interesting case of divisibility. We have to prove that if 2 to the power of n minus 2 is divisible by n, the exponent here, that implies that 2 to the power of 2 to the n minus 1 minus 2 is also divisible by this exponent, 2 to the n minus 1. You see it right here, this right hand side. So if you want to pause the video and try it yourself, you can of course, although I think this is a bit of a challenging proof. It took me quite a while to understand personally. It's not that long, but all you need to see is a few statements that will make proving this much easier. So let's get into some notes here that are going to be important in the future. So first, let's look at this statement we have on the left side, which is going to be our basis to prove the statement on the right side. It's 2 to the n minus 2 congruent to 0 mod n. Right? 0 mod n, this just means divisible by n. We can do simple arithmetic on congruences, obviously, so that implies that 2 to the n minus 1 is congruent to 1 mod n. All I did was add 1 to each side of the congruence, and that works. Alright, for the next statement we're going to look at congruence of 2 to the n minus 1, which is our exponent in what we're trying to prove. By using some simple logic, we conclude that 2 to the n minus 1 is divisible by 2 to the n minus 1. That's obvious, it's going to be 0. I didn't write modulo, sorry. It's going to be congruent to 0 mod itself, right? And again, using some arithmetic, we can conclude that 2 to the n is congruent to 1 mod 2 to the n minus 1. Again, all I did was add 1 to each side. So as you see, we get quite an interesting result here, that it seems the subject of the congruence and the modulus are kind of switched in both places. We can switch the n, the 2n, well actually, no, not really. But still, they have some similarities, and they're going to be both useful in the actual proof. And one more thing to note, finally, is just the definition of congruence. We're going to have to remember it. If A is congruent to B mod n, there exists an integer k such that A is equal to B plus mk. Just by definition. This implies the statement n is both the converse of it. So now we can begin the actual proof. So first let's rewrite our first note we took, which is 2 to the n minus 1 is congruent to 1 mod n. And we're going to rewrite it in such a form where we multiply by an integer k. Okay? That means, let's rewrite it, it's going to be 2 to the n minus 1 is equal to 1 plus nk by some integer, for k is some integer. Great. And remember, again, our objective, we have to show that 2 to the power of 2 to the n minus 1 is congruent to 2 mod 2 to the n minus 1. Or, again, if you subtract 2, it's going to be divisible by 2 and minus 1. This is just our statement up here on the right-hand side. I just moved the 2 over to make it a bit easier. And now this is where the fun really begins. See this exponent 2 to the n minus 1, we say that is equal to 1 plus nk. So we can rewrite that as 2 to the power of nk plus 1, 1 plus nk, same thing, is congruent to 2 mod 2 to the n minus 1. We just use the substitution from our first statement we have here, right? Makes sense? Which means that, using some exponent rules, it's going to be 2 times 2 to the nk is congruent to 2 mod 2n minus 1. And I think you may see where this is going already. Look at our second statement we have here. Remember that 2 to the n in the world of modulo 2 to the n minus 1 is going to be congruent to 1. So here, when we have 2 times 2 to the n to the power of k, again some exponent rules, basic, 2 to the n in the mod 2n minus 1, which we have right here, is going to be 1. And we get 2 times 1 to the k by using substitution from our second statement. Is congruent to 2 mod 2n minus 1. And obviously 1 to any power is 1. So this just gets removed, and we get a true statement that 2 is congruent to 2 mod 2n minus 1. And we have therefore shown, because this is a true statement, that the congruence we want to prove of 2 to the 2n minus 1 is congruent to 2 mod 2n minus 1, only using this basis. And thus the proof is done. So yeah, there's this few tricks here. We had to know this first, but after we noticed that, there's just some basic logic we have to do to conclude our proof. And that is it. Thanks for watching.